Hello students, let's start new chapter number 12, algebraic expressions. Now these algebraic expressions you know, like x plus 3, y minus 5, 4x plus 5. This expression you have learned in chapter simple equation. Now what is algebra? Algebra is a branch of mathematics, and in this algebra, algebraic expressions are the central concept. And in this chapter, we will learn this algebraic expression, as this chapter is devoted to algebraic expressions. When you learn this chapter, you will come to know how algebraic expressions are formed, how they can be combined, how we can find their values, and how they can be used. Okay, now we will learn how are expressions formed. When we combine variables and constants, we get algebraic expression. What is variable? The variable can take various values. That means its value is not fixed. So therefore we denote variables with letters xy, lm, ab, pq, any alphabets. What is constant? Constant, that means each has fixed value. That means, for example, here we can see that some numbers 400. These are fixed values. These have 4 has a fixed value, 4 only. 100 minus 17, 1.2, 3 by 2, minus 1.2, minus 3 by 2. These are constants. Now, when we combine them, that means, for example, first 4x plus 5. Here we can see that number 4 is multiplied with the variable x, and this whole part 4x is added to the constant 5. We get the expression 4x plus 5. Next, here 3x square minus 5. So here, first what we have done, here number 3 is multiplied with x. Again it is multiplied with x, so we got 3x square. And from this 3x square, when we subtract constant 5, we get the algebraic expression 3x square minus 5. Here 4xy plus 7. Here when we multiply number 4 with variable x and variable y, and when we add this multiplication to the constant 7, we get 4xy plus 7. Next, terms of an expression. Now, as we have seen these two examples, this example we have seen first 4x plus 5, and this is another example 3x square plus 7y. So how 4x plus y created? When 4 is multiplied with x and it is added to the term constant 5. So we got 4x plus 5. And here 3x square plus 7y, here 3 is multiplied with x and again multiplied with x, we get 3x square, and then it is added to this part 7 and y, that is 7y. So we got the expression 3x square plus 7y. Now here you will find that the expressions we deal with can always be seen this way. They have parts which are formed separately and then added. Such parts of an expression which are formed separately first and then added are known as terms. So here, in this question, what we have done, this first, this part 4 and x, it is separately formed. That is 4, number 4 is multiplied with x, variable x, and that is 4x. And then this part is added to the other part, that is here constant 5. So that's why then we have found this expression. So this part is called the term. So here in this expression 4x plus 5, 4x is a one term and this constant 5 is another term. Here this constant 5 is also called constant term. That means here in this term variable is not there, only the constant there. So that's why this term is called constant term, and this term is having a variable x. So that's why here 4 and x, this is a single term, one term, and this 5 is a second term. Similarly, first this 3x square is created, okay, then it is added to the another part, that is 7y. So here there are two terms, 3x square is a one term and 7y is a second term. Another example, 4x square minus 3xy. Here first number 4 is multiplied with x and again it is multiplied with x, we got 4x square. And here this here for minus 3xy, first minus 3 is multiplied with x and then it is multiplied with y. Now why we have taken minus 3, not only 3? Because in this expression, in this chapter, to what we will do not write subtraction, we will do not tell subtraction, we will tell that this 4x square is added to minus 3xy. We here in this chapter we will use added only. So here what we can say that 4x square is added to minus 3xy. So first this part 4x square was formed, then this part minus 3xy is also formed, and then when they added together we got this expression. So here first term is 4x square, second term is minus 3xy. Next topic, factors of the term. Here a term is a product of its factors, means here we take this expression 4x square minus 3xy. We can see that directly that here two terms are there, one is 4x square and another one is minus 3xy. So first term 4x square. So how this 4x square formed? So when we multiply number 4 with x and again with x, so we get 4x square. So these 4 x and x are called the factors of the term 4x square. That means a term is a product of its factors. So when we multiply these factors 4x and x, we get the term 4x square. Similarly, in minus 3xy, how this minus 3xy form? When we multiply minus 3 with x and with y, we get minus 3xy. That means this minus 3 x and y are factors of minus 3xy term. Next, now to represent these terms and factors, we use tree diagram. Okay, how this tree diagram forms? First you have to write expression 4x square minus 3xy. Then you have to use continuous line, and whatever many terms are there, that much part you have to divide. So here two terms are there, 4x square and minus 3xy. So here using continuous line we have divided into two parts. In first part we have written terms 4x square, and in second part, second term minus 3xy. Now here afterwards we have to write factors. Now for factors we have to use this dotted line. Keep in mind, to represent terms in tree diagram you have to use continuous lines, and to represent factors you have to use this dotted line. And usually use scale and pencil. You have to use scale and pencil to draw this continuous and this dotted line. Here 4x square. So what are the factors of 4x square? That is 4, x and x. Here this minus 3xy. So what are the factors of it? That is minus 3 x and y. Keep in mind again that here if subtraction is there, so that whole term you have to take. As we usually says that 4x square is added to minus 3xy. So here we have took the term minus 3xy. Its factors are minus 3x and y. Another example, here expression 5xy plus 10. Here we will draw the tree diagram. Here you have to write expression 5xy plus 10, and then you have to draw the continuous line. As here there are two terms are there, so here we will divide it with two terms. Here we will write terms, then we will write the first term 5xy, and here you have to write the second term, that is 10. Now you have to write factors. Now for factors you have to draw dotted lines. Here there are three factors are there, 5, x and y. So these three dotted lines you have to draw, and you have to write 5, x and y. Now keep in mind, first the number will come, afterwards variables. Here in 10, factors of 10 are 10 ones are 10. We do not have to write 5 multiplied by 2. You do not have to here write that way, dotted line, then 5 and 2, because in this algebraic expression for the numbers we have to write only the same number. We do not have to factorize it further. Okay, so here for 10 we will write only 10. We do not have to make the factors of it. Next topic, coefficients. What are coefficients? Now the numerical factor is said to be the numerical coefficient, or simply the coefficient. For an example, if we take this expression 5xy, so in this the number, whatever the number is there in that term, that is called numerical coefficient of that term. Here 5 is the coefficient of the term. Also we can say that 5 is a coefficient of xy. 5 is a coefficient of xy. Here xy meaning x and y is in multiplication, so we have to speak xy only. So 5 is a coefficient of xy. Now another example we will take 10xyz. In this term 10, this number 10 is a numerical coefficient of the term, or we can say that 10 is a numerical coefficient of xyz. xyz. Here xyz are in multiplication. Now here you have to note that for numerical coefficient 1, we do not have to write anything in the expression. That means if 1x there, so we have to write only x. We do not have to write 1 before the variable. So for 1x there, so only x. If 1y there, so only we have to write y only in expression. This is for plus 1. But what about minus 1? If minus 1x is there, so you have to use only negative sign. You do not have to write minus 1, you have to use only negative sign. So for minus 1x in expression you have to write minus x. That means this minus x tells that coefficient, numerical coefficient of this x is minus 1. If minus 1 x square y square there, so you have to write minus x square y square. Now the word coefficient is used in a more general way. That means if phi xy is there, so you can say that phi is a coefficient of xy. Here that means phi is a numerical coefficient of xy, but you can also say that this x is a coefficient of other factors. That means phi and y. So x is a coefficient of phi y and y is a coefficient of phi x. You can say that in general sense, what we say that phi is a coefficient of xy, x is a coefficient of phi y, and y is a coefficient of phi x. Similarly, next example, 10xy square. So here 10 is a numerical coefficient of xy square. We can say that x is a coefficient of 10y square and y square is a coefficient of 10x. So thus in more general way, a coefficient may be either a numerical factor or an algebraic factor. Next topic, like and unlike terms. So here, what is like term? When terms have the same algebraic factors, they are like terms. Algebraic factors mean the variables. So here when the terms have, if we compare two terms and their two terms have same algebraic factors, that means same variables, then we can say that they have a like terms. When terms have different algebraic factors, they are unlike terms. Now for an example, we will take this one expression 2xy minus 3x plus 5xy minus 4. How many terms are there here? 1, 2, 3, 4. Here 4 terms are there. Now we will compare these two terms 2xy and 5xy. Now when we factorize it, we get 2 multiplied by x multiplied by y. So 3 factors we get 2, x and y. Out of these 3 factors, algebraic factors are what? X and y. This variable x and y, they are algebraic factors of 2xy. Similarly in 5xy, factors are 5, x and y, and out of these 3, x and y are the algebraic factors. When we compare these two terms with their algebraic factors, we can say that these two terms having same algebraic factors, here x and y and here also x and y. That means these two terms are having same factors, that's why these two terms are like terms. Another example, here from this expression, if we take this two term 2xy and minus 3x. Now in 2xy, as we have seen earlier, these are having factors 2x and y, and x and y are the algebraic factors for 2xy. Now in minus 3x, the factors are minus 3 and x, and in this algebraic factor is only x. So here when we compare these two terms, 2xy having algebraic factors x and y, and minus 3x having algebraic factor only x, not y is not there. So that's why these two terms are not having same algebraic factors, and that's why we write these are unlike terms. Now you have to keep in mind some things here when we find like terms and unlike terms. That number 1, ignore the numerical coefficient and concentrate on the algebraic part of the term. I have said earlier that in terms you have to concentrate only on algebraic factors. That means it's variables. Okay, so here 3xyz and 7xyz, these two terms are there. Now what we have to do, we have to concentrate only on its algebraic factors, that is x, y and z, and here also x, y and z are algebraic factors. That's why these two are like terms. You do not have to consider on their numerical coefficient. Okay, keep in mind. Second one, check the variable in the terms, they must be the same. Now here what you have to do, first of all, without making factors, without writing the factors, you have to see directly in two terms their variables. If the variables are same, then you have to find their factors, their algebraic factors, then you have to compare them. If the variables are different, then directly we can say that they are unlike terms. Here 3xy and 4xz. Here directly we can see that here variable x and y there, here variable x and z there. So here y and z, they are different here. So these two terms are unlike terms. You do not have to write their algebraic factors, then you have to compare. Okay. Next, third one, check the powers of each variables in the terms, they must be the same. Now if the variables are same, then you have to see their powers. Here two examples are there, two terms are there here, 3x square y and 7xy. So here first what we have to see, variables, here x and y there, here x and y there. But now when variables are same, you have to see their powers. Here x has a power 2 and here x has a power, nothing is written, then it is 1. So x has a power 1, here x has a power 2. So therefore these two terms are unlike terms. They do not have same powers. Yes, variables are same, but power is not same. That's why these two terms are unlike terms. Also you have to keep in mind, when you decide like terms, two things do not matter. Number one, numerical coefficient, as we have discussed earlier, and number two, the order in which the variables are multiplied. For an example, in some terms you can find the order of the variables is changed. For an example, here one term is there 3x square y and another one is there 7yx square. Here order of variables is same. Here first x comes and then y comes. Here y comes first in second term and x square comes last. So here we can see that they are having same variable, order is changed, but x and y and x, here x and y there. Now you have to see its power. Here x has a power 2, here also x has a power 2, y is a power 1, here also y is a power 1. Order is changed, but we do not have to consider their order. We have to see only their variables and its powers. If they are same, then they are like terms. So here we can say that this 3x square y, term 3x square y and term 7yx square, they are like terms. Next topic, monomial, binomials, trinomials and polynomials. Now what is monomial? An expression with only one term is called monomial. An expression with having only one term. For an example, here we can see that 7xy. This expression having only one term, so that's why it is called monomial. Second one, minus 5m. This expression is also having only one term, so that's why it is monomial. And this constant 4. If there is a constant term only there, only 4 is there, so here it is called also monomial. Next, what is binomial? An expression which contains two unlike terms is called binomial. Here we can see that, for example, x plus y. Here two terms are there, x and y, and they are unlike. So that's why this expression is called binomial. Next, m minus 5. Here two terms are there, m and minus 5, and they are unlike. So that's why it is called binomial. Similarly, a square minus b square. This is a binomial expression. Next, an expression which contains three unlike terms is called trinomial. Three unlike terms. For an example, x plus y plus 7. Here we can see that three terms are there, x, y and 7, and they are unlike terms. So that's why this expression is called trinomial. Similarly, ab plus a plus b. Here we can see that in first term there is a and b are in multiplication, second term only a there, and in third term only b there. So these are unlike terms, and that's why this expression is called trinomial. Now we will see the expression which are not trinomial. First, here we can see that ab plus a plus b plus 5. This is expression. It's having four terms, 1, 2, 3, 4. So that's why it cannot be called trinomial. Next one, here we can see that in expression x plus y plus 5x. Here x plus y plus 5, three terms are there. But what is the definition of trinomial? That which contains three unlike terms. Here we can see that in this expression, this term x and this 5x, they are like terms. So that's why here total number of unlike terms is only 2. Y and x and 5x. Only two terms are there. That's why it does not call trinomial, but it called binomial. So in general, now we have defined monomial, binomial and trinomial. What about the 4 term? If expression having 4 term, what about 5 term? What about 6 term? So in general, what we can say that an expression with one or more than one term is called polynomial. So all the expression are called polynomial. Monomial, binomial and trinomial are also called polynomial. Okay, so let's revise what we have learned today. Expression. What is expression? Expression is like that, x plus 4. When we combine variable with constant, we get an expression. Here, x plus 4, here x is a variable and this 4 is a constant. Then we have learned about term of an expression. What is term? So here we can see that this expression 4xy plus 3z. Term is a part which is formed separately. Here 4xy is first formed separately. When multiply number 4 with variable x and y, we got 4xy. Then this part is added to the other part 3z, which was also formed separately with 3 multiplied by z. And then we have added these two parts, we got the expression. The term is what? Part which was added. So this 4xy is a one part and 3z is a second part. So this part are called terms. 4xy is a one term and 3z is a second term. Next we have learned about factors of the term. Here for 4xy minus 3z, 4xy is a nothing but a product of the factor 4x and y. So these 4x and y are called the factors of the term 4xy. Similarly for minus 3z, here minus 3 multiplied with z, we get minus 3z. So minus 3 and z are called factors of the term minus 3z. Then we have learned about coefficient. Here for phi xy is a term there. So in this term, phi is called numerical coefficient of the term, and also it is called phi is a coefficient of xy. Also we can say that in general sense that phi is a coefficient of xy, x is a coefficient of phi y, and y is a coefficient of phi x. Then we have learned about like and unlike terms. If we consider these two terms 4xy and xy, so first of all we have to see their variables. Here variable xy there and here also variable xy there. Then we have to consider their power. Power should be same. Here we can see that this x is a power 1. Here also x is a power 1. Here y is a power 1. Here also y is a power 1. That means these variables are also same and their powers are also same. That's why we can say that this 4xy and 9xi are like terms. Next, this here 4x square y and 9xy. These two terms, now we have to compare them. They are like or unlike. So here we can, first of all we have to check their variables. Here x and y variable there, and in this term x and y there. Now we have to check their power. Here x is a power 2, here x is a power only 1. So these are not the same terms which are having same algebraic factors. So that's why these two terms are unlike terms. Then we have learned about monomial, binomial and trinomial. What is monomial? An expression having only single term, that is called monomial. For an example 4x and also a constant term 9. Then we have learned about binomial. What is binomial? An expression having two unlike terms, that is called binomial. So here for an example 4x plus 9, here two are unlike terms and total two terms are there, that's why it is binomial. In trinomial, what is trinomial? An expression having three unlike terms. So here for an example 4x plus 9y plus 3. So here total 3 terms are there and they are unlike. So that's why this expression is called trinomial. Now polynomial. What is polynomial? An expression having one or more than one term. It is called polynomial. So monomial, binomial and trinomial are also polynomial. Another expression which are having more than 3 terms are also called polynomial. This 4x plus 9, 4x plus 9y plus 3, 4x plus 9y plus 3z plus 1. These are the examples of polynomial.